Okay, I'm back to the idea of the limits, this time using examples. How do we find the limit of x squared multiplied by 2 minus x as the x value approaches 3, as x gets near 3? So for now, let's take a look at this graphically. So what I have is I have a Desmos graph with that. So here's my graph for that function. Y is equal to x squared multiplied by 2 minus x. So you have this essentially a cubic function. And then we're concerned with the x value of 3. So let me see. Let's take a look at this graph. Let me zoom this in. As the x value gets closer and closer to 3, as the x gets closer to 3, what's happening? Okay, what is the y value becoming? Okay, so from the left side, it's getting closer and closer to -9. From the right side, is if you get closer to 3, it's also getting closer and closer to -9. So -9 appears to be the limit for the first one. And for the second function, it's a rational function. I have the graph of that prepared already as well. Okay, we're concerned with the x value of 2 for this function. So if you take a look at this, as the x value is getting closer and closer to 2 from the left side, the y value is approaching 3. And the same thing from the right side, as the x value is getting closer and closer to 2, so it's decreasing. As the x value decreases to 2, your y value becomes 3. Okay, it is also defined at 2, x equals 2 as well, to have the y value of 3. So the limit does match the defined value at x equals 2. But in any case, okay, so the limit of this expression as x approaches 2 appears to be 3. And the third one I want to show you, this topic is also covered in page 60, the bottom half of page 60. It's good to read that section. I would recommend you to read that section. But okay, if not, I want you to know that the limit of sine of x over x as the x value approaches 0. Let's take a look at the graph for that. Okay, limit of the sine of x over x as the x gets close to 0 from either side. From the left side, it's getting closer and closer to 1. From the right side, as you decrease the x value to be close to 0, your y value becomes closer and closer to 1. So the limit of sine of x over x as x value gets close to 0 appears to be 1. Okay, this is something that I want you to try to memorize for now. Eventually, we'll learn to prove this as well. Okay, for now, we'll assume that the limit of sine of x over x as x approaches 0 will be 1. And we'll use that for other problems relating to this.